good evening from me and my green project beast. This time I have a broken blower motor. I'm pretty sure it's a switch because it doesn't feel like it functions anymore. So I'm gonna guess that's what's wrong with it, but I don't know. So with the key on and this fan on, you can hear I have one speed. Maybe you can't hear it, but I have low speed and that's it. This doesn't affect it at all. And so these kind of have a funky wiring to them where the fan has 4 speeds and there's 4 wires going to it. So when you turn on this switch, the low speed wire has power all the time. And then this switch takes that power and then will either block off the other 3 or give it to medium low, medium high, or high. So whenever this is on, electricity will take the path of least resistance. So when it gets to the resistor, it goes to the path of least resistance. So it doesn't matter that that first wire has power because it's going to go to the next resistor that has less power. So that's how they did that. I thought that was kind of cool. It took me longer than I care to admit to figure that out. So I'm guessing that's what's happening here. So I'm going to take this apart, see where I do and don't have power back here. But I'm going to start by unplugging the coil under the hood. Because when you turn the key on to test this, that coil has constant power. If you don't unplug it, it's just going to get hot and it's going to ruin it. I don't really want to ruin my coil, so I'm going to go unplug it. Here I am under the hood. There's a coil, and it's as simple as just taking this little plastic thing and sliding it right off. So now it can't get hot when the key's on. It also won't start though, but that's okay. I don't need it to run. So with my coil unplugged, I'm going to start removing the stuff off this faceplate so I can get this temperature control removed. We'll start with the radio. These knobs just pull straight off. Make sure to drop it. These unscrew from the radio, at least they should. Maybe they just pull off too. Nope, yeah, they also just pull straight off. These switches, on the other hand, have a tab on them. They're just kind of like a tension fit, so you have to press on them so they go flat, and then they'll slide right off. Now we'll just take out these 2 Phillips screws at the bottom. And then this face plate should almost fall off. Except it doesn't want to. There we go. Pulls off and it slides down. Out of the way. So that face plate removed, a 1/4 inch nut driver here. Taken out the, in my case, 3, there should be 4, there's 1 missing, bolts for the HVAC head unit. Should be a way to get that to come out and forwards. Yep, there we go. If you can see in there at all, my diagnosis of this is going to be a little bit different than what would be normally factory, as I added a relay to take the amp load of the fan, so all the 30 amps of the full blast of the fan wouldn't be going through this switch here at the bottom, because they're known for melting and then not working. And that happened to this car, and I ended up taking 2 rivets, drilling out 2 plastic rivets. Hopefully you can see here my fingers at the end of my finger. There's 2 bolts that I put where the rivets used to be. Cleaned up the switch, bent the tab back, and got it down to 1 ohm of resistance. And so now all that switch does is close the relay. And so that will keep that from melting ever again. So because you cannot buy these pieces new or even like remanned. So what you have is what you got. I'm going to take out these 3 Phillips screws that hold the mount for the ashtray so I can get underneath of it. So now I have my better access to my unit here. This screw holding the switch on is a single Phillips, so we'll go ahead and remove that. And remember, I'm going after the switch first for a couple of reasons. One, it doesn't feel like it used to. It feels really clunky and kind of hard to move. The second reason is that this blower motor is brand new within the last couple of years, and you literally have to remove the metal fender to change it or to unplug it. So I'm going to do that absolutely last thing. I'm going to check the easy stuff first, and I know the fuse is good because, you know, it's spinning a little bit on speed 1. So this is my first logical point of progression here. So this switch slides out of the back of the control head, and hopefully I can pull this out a little bit further. I'm going to unplug this very carefully because I don't want to break the clip. This actually is a replacement clip anyway, so it wouldn't be the end of the world. Spliced into the thing, because these clips always melt, so who knows, I could even have a melted clip and I have to do this again. Not impossible. Try not to pull on the wires too much, and that is exactly what happened. I have a melted connector. It's 30 amps of current going through this stuff, and it doesn't normally like it. Wow, that's a good one. So these wires I actually took out of this plug and wired them up best I could, color to color. So I have red to red and orange. I have orange to orange with black tracer. I have green to green with a green tracer, and then white to yellow with a red tracer. So I got them as close as I could and then move these around. So I'm gonna poke at this connector to see which one of these has power. I think it's the orange one, but I could be wrong. But very burnt, so I definitely need to get another connector. It's unfortunate. It's not that old. So I have my voltmeter or multimeter connector lead to ground over here. Turn the key to the run position. You can hear I have my low fan speed because this switch is on. So put it to vent. So just to make sure, off, fans off, low fan speed. Push that back in here. So I should have battery voltage at one of these wires. I have 4 volts there. There we go, 11.7 volts there. And then this, 7 volts there, and 5 volts here. So what you're seeing, the reason these have voltages, it just voltage back feed from the resistor. So this is your power right here, which is the red wire right in here in the middle. This here should be your medium low. This should be your medium high, and this should be your high. So I'm gonna go stick a power wire between these to make sure that the fan works. So this red wire also goes straight to the blower motor resistor low speed. That's why the fan's on right now. So I'm gonna shove this in. Oh. Don't know how I didn't blow the fuse, but just dead shorted it. Hopefully the radio still works. Oh, good. Anyway, so we have power, so now we should have medium low. Yep, medium low, medium high. Nope, I had them completely backwards. So right now I'm on low, it's medium low, medium high, and then high. So this verifies that all my wiring is completely fine past this switch. Then turn that off. So this switch is the original switch. So I don't know if there was a bad connection here or if there was a bad connection in this switch that caused, or the heat transferred through the steel and caused this to melt. Not really sure which. But either way, I'm going to get a new pigtail because it's burnt. When this happens, the metal will move away from its contact and then break connection. So I'm going to get a new switch and a new pigtail and splice this back in. It is now a couple days later. I got a new pigtail and I got a new switch. I got these both from partsgeek.com. The pigtails are fairly easy to find at like parts stores. For example, O'Reilly's sells the standard brand. That was the pigtail. Part number is S625 or 22179. I'm pretty sure it's the S number here. The switch, on the other hand, is a little bit harder to find. Not used or original. I wanted a new one. Parts Geek didn't end up having one that wasn't some like sketchy website that gives you all kinds of viruses. The part number for this one is 35975 from Four Seasons. They are completely identical. The bracket is the same, except this one's a lot less burnt. So, like I said earlier, I'm not sure if I had a bad connection here and that's what got hot, or if there was a bad connection internally in the switch and the heat transferred through this and this was just the weakest point. I don't know. I guess I could open this up and that would tell me. Let's do that. Have some needle nose pliers. You should be able to just uncrimp all of these tabs and the switch will come apart. And there we have it. We have the inside of the switch here. This part of the switch is very melted. These contacts don't look that great anyway. I'm guessing this is where the heat came from. I'm going to do the super cringy thing of just cutting these wires and just splicing the new wires onto like the old new wires. I do not want to cut the original wires any shorter than they already are. There's no burnt connections here. Everything has a firm connection. So I am just going to, well, maybe that one's a little weird. Nope, it's fine. So I'm going to go ahead and just cut these and splice back onto this. So as you can see, my new pigtail has an extra wire, whereas this old one didn't. Now I'm going to go ahead and remove this because I just simply don't need it. Now most clips that you'll come across, even in new cars, have some way of taking the clips and wires out of them. Sometimes they'll have a different colored insert that keeps the tabs from being able to be pushed over in the first place to be released. But in this case, you take a pick like this, and there's a little clip in there, you push it over, and the wire just falls out of it. It clips into this little square right here. You want to push it back in. Get it lined up. There you go, and it's clipped and then it won't come back out. As soon as I release it, there you go. So I use this for test lead or whatever I want to do with it, but I don't need it. Don't need things any more complicated. It's going away. Other than that, all my colors are in the same locations. I'm going to make sure that my key is off so I don't cut any live wires. Will it hurt anything at 12 volts? No. But I want to short something out and blow a fuse? Also no. And also, if you're worried about it, just cut them one at a time. So I have wire strippers. Let's see, what gauge wire is this? It's like 12 stranded. And give them all a quick clockwise twist just to help keep them together for when I put them in the butt splice. And then, since am using the old pigtail, I'm just going color to color. And then one more thing here on butt splices and crimping tools. You'll notice that these are not heat shrink type splices. This is under the dash, it doesn't get the weather. These are perfectly fine under the dash where they're not going to get corroded and water damage and all this other fun stuff. Because if you have water damage in this, you got bigger problems. So this is totally fine. Under hood or under car, absolutely not. But here, just fine. The next thing is these have a crimping tool up here. There's non-insulated, insulated, and then smaller insulated. And these skinnier tools, if you look at them, one's a lot thicker than the other. Tools that are thin like this, when you put any kind of pressure on them to crimp, a lot of times they'll just fold sideways away from each other, and then the crimp is sideways and it doesn't hold as good, and these things, they're basically junk. You get a good solid thick pair like this, and then they just physically can't. These do a really, really good job. I will never go back. These particular ones are from Snap-on. Part number is 29 ACF if you are curious. I personally went to the Snap-on dealer myself locally here in town to get them, but I would imagine they have a website. I've never used it. But with that being said, let's splice our wires. And I will be using the insulated version of the crimpers, not the one with the big divot in it. I want the one that has a little divot in both sides. Otherwise, you can crimp the insulation so much that it tears and then becomes exposed. And give it the tug test. It's good. So one last check, tug, 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 tug. So those are all good. Get this in a spot where I can get to it. Gonna go ahead and pop this in. Turn my key to the run position. And let's see, that sits like this. So this should be low. I must have it completely backwards. Yep, I sure do. Yep, goes like this. So there's low, medium high, and high. So I have all my speeds. Nope, goes the defrost and you don't have any vacuum. Okay. So now I can have air conditioning again. So now this is just a matter of putting it back together. Get my dowel pins lined up there. Now with my switch reattached, plug my wires back in. resituate this. Got my I have my nut driver with screws on it here. Next is the ashtray. Let's again reinstall the light by squishing the tabs, releasing them. Reinstall the ashtray by lining up the grooves. Now we are back to installing the faceplate. Install the top two tabs and push it on just like that. Be careful just to run these down, not even really snugging them, because this is old plastic. You do have to be careful with it. These knobs do have a flat spot that corresponds to the flat spot on the radio tuning knob and volume knob. So put them over the shaft and rotate them slowly while applying pressure so the slot lines up, and then they will slide on. Do the same thing over here. Wow, okay, just nailed it first try. The tuning and volume knobs here are the same way. Just hold them straight, rotate them, push them on. These just are held on by friction. And then down to our HVAC control knobs. Line it up, push it on. Line it up, push it on. And finally, our temperature lever. There we go. Now I should have low, medium low, medium high, and high. I'm going to start it up and see if I have air conditioning. Remember to plug my coil back in here. Start this up in my closed garage so I can suffocate. AC works. If you like this video, if it helped you out in some way, feel free to like and subscribe.